going to talk about increasing functions. First of all, let me give you a definition of what we mean by increasing function. First definition, a function is increasing if for every value of x sub 1 and x sub 2, for every value of x sub 1 and x sub 2, wherein x sub 1 is greater than x sub 2, f of x sub 1 is greater than f of x sub 2. This is the definition for an increasing function. The function is an increasing function if for every value of x sub 1 and x sub 2, x sub 1 and x sub 2 just represent values of x. So the function would be increasing if that is the case. For example, suppose we have this function. F of x equals 2x plus 5. And suppose that we want to determine whether or not this function is increasing or decreasing. Now, as you look at this function that we have here, what kind of function is this? Is it a linear function? Is it a quadratic function? What kind of function is it? If you said linear, you're right. Because here, x is to the first power. You recall that a first degree equation, if x is to the first power and y is to the first power, then we have a linear equation. Of course, f of x is the same thing as y, so it's to the first power. We want to determine today this function that we have worked with before. We want to determine whether this function is increasing or decreasing. And we look at the definition here, and it says that for any value of x sub 1 and x sub 2, wherein x sub 1 is greater than x sub 2, then f of x sub 1 has to be greater than f of x sub 2. This is for any number within that set of numbers that we have for x. So what we need to do here, we need to first choose two numbers. Choose two numbers such that the first number is greater than the second number. Now we can choose any two numbers that we want to choose. It's totally up to you which two numbers you choose, but the first number has to be greater than the second number. And once you see that the first number is greater than the second number, then you find f of the first number and you find f of the second number, and f of the first number must be greater than f of the second number. If this is not the case, then the function is not increasing. It's not an increasing function. Now, a function does not have to be an increasing function. As we said, a function can be increasing, a function can be decreasing, and also a function can be constant. It can be remaining the same. So those are the three cases: increasing, decreasing, or remaining the same, be constant, what we call a constant function. So I'm sure that you recall that if you have an equation like f of x equals 4, which is the same as y equals 4, that would be a horizontal line, so an example of a constant function. So let's see, we want to see if this is increasing or decreasing. So we choose our two numbers here so that the first one is larger than the second one. So let's say I'll let x sub 1 be 4 and x sub 2 be 3. So I'll say x sub 1 equals 4, x sub 2 equals 3. So first of all, I have x sub 1 is greater than x sub 2, and there, in this specific case, I would have 4 is greater than 3. And this statement is true. 4 is greater than 3. Now, if this is an increasing function between 4 and 3, between those two numbers, or in that interval from 4 to 3, then f of 4 must be greater than f of 3. So both parts have to be true in order for this to be an increasing function. Both parts have to be true. It has to be true that the first number is larger than the second number, which you choose these numbers any way you want to. I could have chosen 100 and for the first number and 5 for the second number. Or I could have chosen 7 for the first number and 2 for the second number. As long as the first number is greater than the second number. That's how you have to choose your numbers. So I chose 4 is greater than 3, and this is true. Now, if it is also true that f of 4 is greater than f of 3, then this is an increasing function, or is increasing in the interval from 4 to 3. So sometimes you have functions that are increasing at one time, but they're decreasing at another time. So you have to look at what the function is doing within a certain interval. Because in one interval it might be increasing, then in the next interval it might be decreasing. So here we are looking at the interval from 4 to 3 to see whether or not the function is increasing in that interval. Okay, so we have to find, now we have to find f of 4 and f of 3. So we see that we have f of 1, f of x sub 1 is greater than f of x sub 2. For f of x sub 1, x sub 1 is 4. So we're looking at f of 4 greater than f of 3. Now, if f of 4 is greater than f of 3, since this part is true, if that part is true, then this is an increasing function. Now, to find f of 4, we have to take 4 and we have to substitute it in this equation, 4x. That's what we have to do to find f of 4. So we find out what f of 4 is. F of 4 is equal to, we have f of x equals 2 times x. So that means that everywhere we have x here, to find f of 4, we substitute 4. Once again, to find f of 4, everywhere you have x in this equation, you substitute 4. So therefore, f of 4 is equal to 2 times 4 plus 5. F of 4 is equal to 2 times 4 plus 5. And then we simplify that. 2 times 4 is 8, plus 5 will give us 13. This means that f of 4 is equal to 13. So on this side of this equation, we would have 13 is greater than, now we have to find f of 3. To find f of 3, we substitute 3 into the original problem for x. That's how we find f of 3. So remember, the original problem was f of x equals 2x plus 5. Now we need to find f of 3, because we have to determine whether or not f of 4 is greater than f of 3. If it is, this part is true, we would have an increasing function in this interval. So we substitute, in this case we substitute for f of 3, we substitute 3 in the original equation for x. So that means that right here where we have x, this time we're going to substitute 3. And where we have x on this side of the equation, we're going to substitute 3. So we get f of 3 equals 2 times 3 plus 5. And that's what we have up here. F of 3 equals 2 times 3 plus 5. 2 times 3, of course, is 6, plus 5 gives us 11. This means that f of 3 is equal to 11. Which means that here, where we have f of 4 is greater than f of 3, f of 4 was equal to 13, f of 3 is equal to 11. So there we have 13 is greater than 11. In other words, we were trying to show that f of x sub 1 is greater than f of x sub 2. F of x sub 1 was 4, so we had f of x sub f of 4 is greater than f of 3. We found out that f of 4 was equal to 13, and we found out that f of 3 was equal to 11. Is 13 greater than 11? Yes, 13 is greater than 11. This is true. The original part was true. This means that it's true that x sub 1 is greater than x sub 2 because that's where we chose our numbers. And it's also true by substitution that f of x sub 1, which is 13, is greater than f of x sub 2. So this means that this function is increasing in that interval. It is an increasing function. So we can say f, the function f, is increasing. The function f is an increasing function. So you can check functions out by substituting a couple of numbers in. You can determine by substituting those numbers in whether you have an increasing or a decreasing function. Okay, so that is the increasing function. That's the definition of an increasing function.